guys know I play that every time? I guess got a little fiddle here that I make this rock and roll. Welcome, rock stars, to another video, and this video is about percents. Percents. This is a very, very important video as you transition through the middle school years and even the late elementary school years. But I just got something I got to ask you. It's a super important question. What do you call a train carrying gum? It's a choo-choo train. He chews on the gum. Choo-choo train. Chews on the gum. Choo-choo train. Yeah, these little ditties have lyrics. I don't think you knew that. All right, let's talk about percents, guys. So the goal today is for you to be able to estimate and determine a percent. And so how are you going to estimate and determine a percent? You are going to look at, sometimes you're going to be looking at pictures. Sometimes it's going to be on a number line. Sometimes it'll be a verbal description. A verbal description simply means someone is like it's written out, or it's like a real world, like, you know, a word problem. And these are going to include percents that are greater than 100% and even less than 1%. We're going to get into that. But guess what comes next? It's vocabulary time. Welcome, boys and girls, to vocabulary. Okay, so percents. What are percents? Percents simply are parts per hundred. So it's something out of 100 will give you a percent. Okay, so if you ever have seen someone get a paper graded and there was 100 questions on the test and they got 77 of those questions correct, guess what their percent would be? 77 out of 100. And if you think about a classroom that you're sitting in right now, or maybe you're looking out into the mall and you see a bunch of people walking around the mall. But this time you only see maybe 48 people. Okay, and I ask you a question like, well, I wonder how many of those people are wearing hats. And so you look around your classroom that has 29 kids, and you look around the mall and you see a different amount of kids, but neither of them are 100. And your answer is like, well, I only have 13 out of 48 people that are wearing hats. It's not 13% because it's not out of 100. But we're going to show you how to figure out that percent. So in other words, anything over 100, that number on top is going to be the percent. Okay, pretty simple. Actually, it's not that simple, but we'll get to it. So go ahead and look at the next one. This one's estimate or estimate. So this is when you're doing stuff in math and you're like trying to figure out, or just in the world, where you're just trying to figure out like the approximate or like close to the actual value by doing a little bit of like smaller calculations, but not getting down to the most accurate answer. I want you to think about eating an apple. And if you were eating it and you took like 4 or 5 bites, you would look down and I would say like about what percentage of that apple have you eaten? Or how much of that apple have you eaten? You might say, well, it's not exactly a half, but it's real close to a half. An estimate is finding as close enough to the right answer as possible without going into the complete detail. Okay, so let's work. Let's talk about percent. Again, I told you that percent means per 100. And another way to phrase that is how many out of 100. 7 out of 100 kids were wearing a hat to school one day. 13 out of 100 kids 99 out of 100 kids love my dad jokes. And so 99 out of 100 would be 99% of kids love my math jokes. And you guys, that's just math. You can't argue with it. It's good stuff. It's just good jokes. All right, so that's what that means. But the other thing we really need to understand is all fractions and decimals can also be written as percents. And like, if you could get this through right now where you understand that fractions and decimals and percents all represent the same thing. They're just different ways. Some people like to have their answers in percent. Sometimes they need a fraction. Sometimes they need a decimal. But they all represent the same thing. And let me give you a little quick hint. All standard or normal fractions represent part of 1. So if I have a fraction that has a 7 on the bottom and a 3 on the top, as long as the top number is smaller than the bottom number, it represents part of 1. So it's 3/7 of an apple. 3/7 of the classroom. And you may say, well, there's more than 1 people in the classroom. But I'm talking about the whole classroom. If I say 60% of the classroom loves chicken pot pie, I'm talking about 60% of 1, which is 60% of that one group. Okay, decimals are the same thing, because if you think about a decimal, you're looking at a place value chart, and this would be a 1, and this would be the tens, and this would be the hundreds, right? Over here is our decimals. This is tenths, this is hundredths, this is thousands. And what they're saying is this is all part of this 1. So if I had 0.74, that means I'm somewhere between 0 and 1, so it's part of 1. So if they all mean the same thing and they can all be shifted back and forth to represent the actual same data, then fractions, decimals, and percents can all be written, and we can move around between them. We're going to be doing a lot of work on that. Not as much today, but a lot of work. Okay, do you guys remember this thing? Have you ever seen it? Think back to your early elementary school days. This is a plate or a grid, and there are 10 squares going this way, and there are 10 squares going this way. So if I have 10 rows of 10, that means that this thing represents 100 squares. I just need to make sure you understand that, because we're going to go to the next one and say, now we have a grid that's partially filled out. And we just talked about that it's 10 and another 10 and another 10 and another 10. So that's 4 10s, right? 10, 20, 30, 40. And then we have 1, 2, 3, 4, 5, 6. So I have 46 of these shaded in. Out of how many? Man, did you say something about out of 100 means something? Well, this grid is out of 100. It's 46 out of 100. So what is this grid? What percent of this grid is filled out? Boom! 46%. As long as it's out of 100. That's really, really important. I'm not going to keep circling it. Keep circling it. Keep circling it. As long as it's out of 100, that would be your percent that's on top. Okay? Now, when we think about percents, we really want to make sure we understand, like, their benchmark percents. So if you're not understanding what benchmarks are yet, just think of a fraction. A half is a benchmark fraction, because that's just something that all of us can relate to. We can think of an apple and think about, what does a half of it look like? We can look around our room and say, there's about 20 kids in here. What's half of that room look like? Well, it's 10 out of 20, right? Half is literally, you take the group of whatever you're talking about, you split it directly down the middle so it's equal on both sides. So that would be a benchmark fraction. So when you're estimating, you could say, oh, it's close to a half. And sometimes you're saying that just because if I can say something's close to a half and another thing's close to a whole, I don't have to do all this crazy calculations. I can just say, well, the one that's close to a whole is bigger than the one that's closer to a half. And that's why we use benchmark fractions. Well, now we're going to talk about benchmark percents. So let's look at the most basic benchmark percent, okay? And that would be this one, 0%. What is 0%? That's none. That means out of 100, nothing. Out of whatever the value is, 0% of them are collected. The next one is the second easiest one, which means out of the classroom, how many of the people in the classroom are humans? Well, you can say all of them. So 100% of my classroom is humans. Now I would kind of argue with that a little bit, but that's okay. For this sake, let's just act like you guys all are humans. Next up, we'd say 50. 50% is a benchmark fraction. We already talked about it. It's about half of the material, half of the collection, half of the group, whatever we're talking about, half of the apple, half of the pizza. Okay? Then we have 25%. So if we had a group of people, or just a collection of whatever we want to call it, so we have this thing where we have a collection of all these things in here, and we say, let's split it in half. So that's half, and that's half. Just imagine that each side of those is the same amount of data. Well, a quarter, or 25%, would be half of each of those halves. It would be, this would be 25. Well, let me try that again. I'll do it in another color and write smaller. Okay? This little collection would be 25%. This little collection would be 25%. This little collection would be 25%. And this collection would be 25%. Okay? So they're 1/4. There are 4 sections that are 25. And another 25 gives me 50. And another 25 gives me 75, and another 25 gives me 100. So 25% would be about 1/4 of the data of the group, of whatever, 1/4 of the pizza. And it's easy to kind of picture a pizza, right? We just kind of say, here's a pizza, here's half of it, and here would be 1/4 of it, right? So along those same lines, I'm going to keep my pizza drawn right there and say, oh, 75%. Well, this was 25%, this was half of the pizza, and this is 75%. So you take your group and you break it into 4 parts and you say about 3 of them exactly would be 75%. So when we're estimating, we look around the room and say, how many people are wearing hats? You look around and be like, well, not all of them. And it's more than half. It looks like it's pretty close to 75%. These are benchmark percents that we want to make sure we understand. Okay. And there's 2 more that you're going to get into a little later. And I'll just go ahead and give you a quick intro to them. One of them goes about right there and he's 33%. And his cousin goes right over here, and he's about 66%, okay? 66% and 33%, those are thirds. So you look around the room and you're like, it's not a half. It's bigger than a quarter, so it's probably a third, like 33%. And then the other one would be, 66%. Same kind of thinking. All right. But what happens if we get data and it's not out of 100? Well, let's get to 100. All right, so what is this out of? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. And how many of them are filled in? 1, 2, 3, 4. So we have 4 out of 10. So 4%. Wrong. It's not 4%. Because it has to be out of 100 to get the percent. So now we're going to get into that whole thing about equivalent fractions. All right, so we're going to take this fraction and we're going to turn it into 100. We can't just do that. There has to be for it to be equivalent, whatever we do to the bottom, we have to do to the top so that they're making an equal jump on both of them. So it's always going to be multiplication or division, all right? It's always going to be multiplication or division. So what did I do to get from the 10 to the 100? I got bigger, so it's automatically multiplication. And what did I multiply that 10 by to get to the 100? I multiplied it by 10, because 10 times 10 is 100. So let's do the same thing over here. If I multiplied by 10 on the bottom, I have to multiply by 10 on the top. And so 4 times 10 is what? It is 40. I have 40 out of 100. I remember you saying 40, anything out of 100 is a percent. 40 out of 100 is 40%. Boom. There's your answer. Get to 100. Let's do a couple more get to 100s, all right? Let's take this first one and say, let's get to 100. What did I do to 150 to get to 100? I got bigger, so I multiplied. 50 times what equals 100? Well, 2 50s equals 100, so I doubled it, which means I double the top. 4 out of 100. What percent? 4%. Let's go here. Let's get to 100. What did I do from 25 to get to 100? 25, 50, 75, 100. 4 times bigger, so I multiplied by 4, which means I have to multiply by 4. What's 6 times 4? That would be 24. 24%. See what I mean? When you get to 100, life is pretty easy. So this one, let's get to 100. 4 groups of what gets me to 100? Well, you could count by 4s, or you could kind of look back at that last question and say, oh, 25 groups of 4 is 100, so 4 groups of 25 must equal 100, right? So then we multiply the top by 25. And we say 25, 50, right? So we have 5 groups of 25. So 25, 50, 75, 100, and one more 25 gives us 125. Wait a second. That number on top is bigger than 100. Well, that means it's 125%. So this one is more than a whole. 125% of something took place. All right, so now we got this problem. Obviously, we've got more than 100% because if you look at it right now, remember I told you 100% is a whole? Well, I see a hole and I see a hole. I got 2 holes already. And I got this last one that's not quite a hole, but it's got 3 pieces. And what are all our pieces broken into? They're broken into fourths. And how many fourths do I have? 1 potato, 2 potato, 3 potato, 4, 5 potato, 6 potato, 7 potato, 8 potato, 9 potato, 10 potato, 11 potatoes. Is that how you guys count by potatoes? All right. Is that 11%? No, we got to get to 100, dog. So let's get to 100. We put 100 here. And we said, what did I do to get to 100? I got bigger. I multiplied. What did I multiply by? 25. 4 times 25 is 100. What do I do here? Well, I got to multiply by 25. Okay? How do you guys do multiplication of 2-digit by 2-digit numbers? There's standard algorithm. There's box method. There's whatever you have been taught. Let's do this one by the standard algorithm. We're going to say 25 times 11. Okay? So I take my ones place and I say, what is 1 times 5? It is 5. What is 1 group of 2 or 1 times 2? It is 2. We put our 0 here. It's magical. It's not really magical because what that 0 represents is now I'm going to multiply by this 1, which is in the tens place. So I'm not really multiplying by 1. I'm multiplying by 10. So what is 1 times 5? It is 5. Or what is 10 times 5? It is 50. And what is 1 times 2? It is 2. So when we add these up, we got 2 partial products, 5 and 7 and 2. We got that our answer is 275 out of 100. So the percent is out of 100, and we know that it's 200. And what kind of writing is that? I mean, you guys, I am just embarrassed of what you just did right there, guys. You got to get it together. It is actually 275%. Da-da-da-da-da. We just did it. Okay. Now let's look at it in a word. Remember I told you it might be in a real world situation, a word problem, if you will. So Jamie and his friends were eating candy after lunch. Classic kids. And I bet if I really looked into it, they were eating the candy before the lunch. Anyway, they had this big old bag of candy. And in that bag of candy, there were 50 pieces. And when they got done eating, they ate all but 7. What kind of candy eating session are we talking about here? Anyway, so at the end of it, there was 7 pieces left. So the bag only had 7 left. What percent of the candy did the group eat? Well, how much of the candy did they eat? If they had 50, there's only 7 left. Well, let's go ahead and say, what's 50 minus 7? And that will give us 43. So there's 43 pieces of that candy left. And it's 43 what? It's 43. I'm going to go ahead and remember that number. 43, 43, 43. I'm going to erase the screen. 43, 43, 43. All right. It was 43 pieces of candy out of what? Out of 50. We need a percent. We need a percent. We got to get this out of 100. All right. So what did I do to get to the 50 to the 100? I doubled it. So that means I got to double the top up here. What's 43 doubled? What's 43 times 2? 43 times 2. 2 times 3 is 6. 4 times 2 is 8. 86. These guys ate 86% of the candy, and I didn't get any of it. That's just classic kids these days. Classic kids these days. Look at the problems. Break down what they're asking. Set it up so that if it's asking for a percent, that you can get yourself to eventually get to 100. And once you get to 100, life is good. Hey, it's wrap-up time. Let's wrap up this percentage thing. Proud of you guys. You guys are crushing it. Ask all the questions. Do all the things. Get all the help you need. And let's just master these percents. Okay. Why did it get hot in the ballpark after the game? So why did it get hot at the baseball stadium after the game? Should be hot during the game. Oh, I know why. Because all the fans left. The fans are leaving. No, the fans of the game are leaving, but the fans like keep you. That's a good joke. I didn't hear anyone laugh. But thanks for watching. See ya!